Last day to get a little practice with this. Your test is all calculator active. All right. However, what I did for today is I looked at the practice EOC that the state of North Carolina puts online, and I've got all the quadratic questions that were on there for you this morning. Some of them are on the inactive. So this would be one. I know the graphs from your seats aren't going to be the easiest to see, but a couple things we can do with this. First, easy part with the way it looks right there is we're just going to find the zeros. So the first part there, what value of x would make that parentheses equal to 0? 4. So one of our zeros is 4. What about that one? -2. So we need -2 and 4 as a 0. I know you can't read those numbers from where you're sitting, but you can see that's +2, that's +4, so it's not B. That's -2, that's 0, so it's not C. That's -4 and -2, so it's not D. We got -2, +4. Just that alone already got me an answer. If I were making the graphs, I wouldn't make it so like one of them eliminates like everything like that. So you might have to check other things. One of the easier things to check is if you do your foiling. We got 4 times x, and that's 4x. We got our 4 times 2, that's 8. On the inside, we got a -x times an x, so that's a -x squared. And then we got the -x times the 2, so that's a -2x. We have to kind of rearrange the order to get it the ax squared plus bx plus c. But when we do, we got -x squared plus 2x plus 8. When we have a -a value, that's where you get the frowny face. That's the other thing that usually helps a lot in eliminating answer choices. We also then, in that format, we have our y-intercept. Our y-intercept is 8. This one here has 8. That one there has 8. So there's a few things you can check pretty easy without a calculator. Any questions on that one? I think your test has a couple that are kind of similar where it gives you like a function, you got to kind of match it with the graph. Now, with Desmos, obviously that goes. So this was another one that was on the inactive part. And Desmos really wouldn't help you with this either. So go ahead and get the equivalent expression. Do your foiling on that. All right, everything's got it. Yeah. So when we FOIL, first terms, x times 3x is 3x squared. Outside terms, we got x times a -3, so that's a -3x. Inside, we got 2 times 3x, so that's a positive or plus 6x. And then we got 2 times the -3, so that's a -6. And then you just combine. Usually you only have to combine what's in the middle there. So that makes a plus 3x and the -6. Any questions on that one? By the time you get to EOC or the next check-in or anything like that, that's like at least one problem, almost 100% guarantee. Okay? They're going to have you do some sort of foiling. This one was actually on the inactive also. So you see a company models its net income in thousands of dollars with the quadratic function there, where X is the number of units its product sold. How many units of its product does the company need in order to sell a net income equal 0? So it says equal to 0. That kind of gives you a little bit of a hint. We're looking for a 0, right? So when you're doing this without Desmos, with Desmos it's easy. Put the equation in, find where it crosses the x-axis. Without Desmos, if you have an a coefficient, you want to try to factor that out first. 9, in this case, does go into every one of those numbers. 9 goes into 54 6 times. 9 goes into 144 16 times. So remember, do our F, right? We're looking for our A times C to multiply, so that's negative 16. It needs to add to the B value of negative 6. So I got negative 16 that it has to multiply to. That means I got different signs. I got negative there on the bottom that they have to add to. That means my bigger number is negative. So what two numbers would multiply to 16 and have a difference of 6? 8 and 2, and like I said, the bigger one's got to be the negative. If I still had an a coefficient there, I would have to divide a coefficient, but since I can factor out the whole thing, it's good. So what we have is when it's factored, I've got x minus 8, and I got x plus 2. The zeros, what they are, is the opposite sign on what I got on those sides. So, if we looked at each of the parentheses, we're making it equal to 0. So that means I got 8, and I got negative 2 as my zeros. So what's the answer? 8, yeah. It's saying how many units of its product does a company need to sell? Y'all, they ain't going to sell negative 2, right? So you got to sell 8 to have their income equal to 0. Any questions on that one? I said, it'll be on the active, things like that. Put it in Desmos, find the things, and then it's got to be the positive 0. But we may have to do it without. All right, so this I think was one last one that was on the inactive. We need the positive 0 for that function. All right, so what am I missing on that function? A b. We don't have a b. So basically, we'd have like x squared minus 0x minus 121. And you'd be looking for what multiplies to make negative 121 and adds to make 0, right? So if there's no b value, or if we're looking for something to add to equal 0, it's got to be the same number with different signs. So it's like taking the square root of a number. 11 times 11 is 121. So it's got to be positive 11, negative 11 for the answer. This was a problem where you had to type in the answer. So that's why it asked for just one of them. Any questions on that? You'll see stuff like that fairly often where they leave out the b value. This one was actually on the active, I think. So You can use Desmos. Go ahead and find the value of the smaller 0. All right, you can tell me what's the value of the smaller 0. Noah? -2 is correct. All right, so when you put it in Desmos, you're looking for where it crosses. Otherwise, you'd have to factor that one. Fairly easy numbers to factor. If you pull out the 2, you'd have 2 times x squared minus 4x minus 12. So you're looking for what multiplies to -12 adds to -4. So what that would be is x minus 6 and x plus 2. So when you change those to the zeros, that's how you get the -2. Or like I said, Desmos does it for you. One that would be on the active. What we need to do first? Yeah, we got to make it equal to 0. So when we're looking for solutions, that's what you want to do. You want to make it equal to 0 because then you're going to be looking for the zeros. The testing version of Desmos doesn't do that. So you got to move that 121 by subtracting. So we'll have 4x squared minus 52x. And that's going to leave us with a plus 48. And all that's equal to 0. All right, you can tell me the 2 zeros then. 1 and what? 1 and 12. Everybody good with that? All right, so that's the thing. When you have the equations like that, to get the solutions with a quadratic, you need to make it equal to 0. So usually you're going to have to move a number over to the other side. Your test, I don't think has one like this with linear function, but the key to a problem like this is you got to kind of read carefully, all right? It's asking about the y-intercept, all right? Distance between the y-intercepts. So the function they give us, the f of x there, what's the y-intercept? 3. Y-intercepts are c value, right? So we got a positive 3. What kind of equation is this? On the table, what kind of equation? What type of function? It is not a quadratic function. Linear, yeah. How do you ever figure that out? Oh, wait, what? It says right there. All right, so when they give you a table, you can't assume it's a certain type of function. They'll generally tell you, on problems like this at least, what kind of function you're looking at, okay? So since it's a linear function, if you put that table on Desmos, what you'll have to do is that y1 with a little squiggle line, mx1 plus b. That's how you get a linear function from a table on Desmos. All right, so that's a linear function. Let's just pretend if the table were a quadratic function, you'd have to do y1, little squiggle line, a x1 squared plus b x1 plus c. That would give you the equation for a quadratic function. If it happens to be an exponential function, you'd have y1, little squiggle line, you can do a, b, and then your exponent has to be x1. So those are the three types of functions, that y'all work with in 8th grade math. Those are the three ways you get them on to Desmos. Basically, you just kind of use like the basic form that we have for each one. We use the slope-intercept form for that, for the linear functions, and then we're using the standard form for the other two. So, any questions on those? And if you put that table in, it would give you like the y-intercept. That'd be your b value in the linear function. And then you just subtract to find the difference. Any questions on that?